Max Planck UBC Center for Quantum Materials brings together top investigators at 7 Max Planck Institutes and 2 departments at the University of British Columbia. The research infrastructure at these partner institutes is complementary. It includes state-of-the-art sample synthesis and nanostructuring facilities, unique spectroscopic instrumentation, scanning probes, and synchrotron beamlines. In quantum materials, quantum correlations between electrons generate an amazing collective behavior not found in ordinary metals and semiconductors, such as, for instance, unconventional superconductivity. It is our goal to achieve a deep understanding of these quantum phenomena and move towards their control and design. If you're successful, we will be able to build an entirely new generation of quantum devices.
For young students coming to the facility, they have the possibility now to spend time here at UBC, but also spend time at one of the 7 participating Max Planck Institutes where they can utilize the facilities there or here, and they are perfectly free to move back and forth and make the most possible use of very modern facilities and expertise.
The Max Planck UBC research internship is a chance for me as a UBC bachelor student to go abroad to Germany and work at a Max Planck Institute and be exposed to the forefront of solid-state research. I'm working with my colleagues on graphene, specifically the electronic properties of graphene. As is often the case, we're looking at the experimental and theoretical side, and I'm working on a computer simulation which will simulate graphene, its electronic properties, and how those change when I change the structure around it. It's a great opportunity to see the wider science community on a global scale and meet some of the brightest minds in the industry.
I would definitely recommend this center to anyone who is looking for a graduate position in related fields. It provides access to a wide range of both experimental and theoretical expertise, and one gets to work with some of the most prominent scientists in the field. Plus, the working environment here is extremely open and friendly.
Here at the center we are striving to become one of the prime institutions to study quantum materials with spectroscopic and density functional theory techniques. Our goal is really to work on single crystal as well as films grown by molecular beam epitaxy techniques, and we have facilities for this purpose on the Max Planck site, and here at UBC we are currently building the Quantum Materials and Devices Foundry, which is specifically suited for this kind of experiments.
Working in this center has been fundamental for my research because it allowed me accessing different techniques and exploring new fields to study my specific research project. For my future career, it allowed me to deepen my expertise and my experience in selected techniques which are fundamental for the study of quantum materials and which will be fundamental for my future research.
What the Max Planck UBC Center really helps to do is give us access to tools and expertise that we might not otherwise have. So one of the projects that we have is looking at molecules on the nanoscale for photovoltaic applications, for example, and then our collaboration with the Max Planck for Quantum Optics is allowing us to study those systems on the attosecond scale. So we can do both nano and atto at the same time. With Jenny Hoffman coming in the summer of 2015, I really think UBC is poised to be at the forefront of scanning probe microscopy research. We're going to have a really good cluster of expertise and tools that will be in place at that time. Part of that, of course, is the new extension of the current building, which will have another facility like this, which is extremely low vibration and acoustically isolated for making really the best measurements that are possible at this time.
We're headed into becoming one of the leading, and perhaps the leading, research center in the world as far as quantum materials research is concerned. We believe that, that this is a very open center with open ideas. We're trying to attract, of course, the best postdocs and the best graduate students to the center, and the fact that it has such large diversity of expertise and facilities, I think, is a very attractive place to be.
The Max Planck UBC Center is funded at a level of about $1 million per year, and we spend the funding on salaries for students and postdocs, on travel between the different locations, and on workshops and summer schools. We're aiming to become a world-leading research and training center in the area of quantum materials. We just signed an agreement with the University of Tokyo, who will join us next year as a third partner.